Hello everybody and welcome to example 2. We're still looking at page 9 in the workbook here. And this is going to be our second example of doing an integral using the technique of integration by parts. Okay, so I'd like to start off by approaching this very similarly to what we did in example 1. If we just sneak a peek back at example 1, we made the choice to let u be x and to let dv be the second piece. Let's try that out again and just see how it works here. Okay, so if we do that, make that u and ln of x dx dv, then we'd start by just writing down those choices that we made. And as before in example 1, the next step is to figure out the du and the v that kind of go with those choices. Okay, so du is like the derivative of u with a dx tacked onto the end, so the derivative of x is 1 times dx. And dv, if dv is ln of x dx, we need to take an antiderivative of ln of x to get v. Okay, but what would an antiderivative for ln of x be? Well, let's sneak a peek at our list of common antiderivative formulas. And what you'll notice is there isn't one for the natural log of x. Natural log of x is a function that doesn't have a nice, obvious antiderivative. Okay, so going back to our problem, we're kind of stuck here. Okay, and there's not a good way to figure out what v is. Okay, so what that means is we might have to back up and rethink our choices here. Just like with a u substitution, sometimes you make a choice that doesn't work. And this one appears to be a choice that doesn't work for us. And that's okay. So we'll back the train up here and ask ourselves, could we make a different choice here? Okay, we chose u equals x and it didn't work, so what if we try u equal ln of x? There's a different choice. And if we do that, then that means that the remainder of our integral, the x times the dx, would be our dv. Let's write down our new choices here. Okay, and we'll try that out and see if it works. Okay, so let's see. Again, we need the u, the du, and the v that go with those choices. So what is the derivative of ln of x? Okay, well, it's 1 over x, and we'll stick a dx on the end. And if we start with dv equals x dx, what would an antiderivative for x be? Okay, just using the power rule, we would get x squared over 2 for that. Okay, so good. We were able to find a du and a v, and away we go here. So our integration by parts formula tells us that when we integrate u dv, we get uv minus the integral of v du. Okay, fill in the pieces there, and let's see. U and v are ln of x and x squared over 2. Okay, it doesn't really matter what order we write them in because we're multiplying. And the integral looks like the integral of v, which is x squared over 2, times du, which we can see from our work as 1 over x dx. Okay, and to finish this problem, we need to calculate the integral that we're looking at right here. Okay, now you might look at that integral and think, God, that looks like kind of an ugly integral. It's actually not as bad as you might think because we can do some simplifying here. Okay, in particular, notice that x squared and x, we can cancel one of those x's and get an x in the numerator. And then there's also a 2 in the denominator that's a constant that can be pulled outside of the integral. So if we do both of those things, take that minus a half out, all that's really left in the integral is x. Okay, so we need an antiderivative for x. And we can do that using the power rule. Remember, again, that's x to the first power. So we're going to raise the power by 1 and divide by the new power. And our antiderivative is going to look like x squared over 2. And we'll put a plus c on the end because we're looking at an indefinite integral. Okay, and we're basically done. We could maybe do a little bit of simplifying here. So we've got two 2's in the denominator. How about if we put those together into 1/4? So we've got minus a fourth x squared plus c. And there's our antiderivative. Okay, so again, we haven't said a whole lot so far about how we're making these choices for u and dv. In the next video, we'll start out by just kind of talking about that general problem. How can we make a good choice for u and dv? There are some guidelines that will help us.